Before you watch this video, I want you to put your pen down, close your book, and just listen to whatever I'm saying.
Imagine a couple, a very crazy couple. Now the guy wants to give the girl a rose. If she lives beside his house or opposite to his house, then he can simply jump the wall or just do something of that sort and give her the flower, which might take about 5 minutes. If she lives 2 lanes or 2 streets away from his house, then he either walks or takes his bike and goes there to give the flower, which may take around 30 minutes or even more. But if she lives in another country, then he has to take a flight. He has to catch a flight and go to that country and then give the flower, which might take around 2 days or even more. So, if you observe something, as the distance between both of them is increasing, the time taken to deliver the flower is also increasing linearly.
Now, slowly come out of the story. Open your book, hold the pen, and let's get back to the topic.
Similar to the previous scenario, as the size of the code keeps on increasing, the time taken to compile that particular code, or you could say execute that particular code, also increases linearly. Let's talk about this thing after a few minutes. First of all, let's understand what is time complexity. Let's look at the definition first. Time complexity is the amount of time taken by an algorithm to run as a function of the length of the input. It measures the time taken to execute each statement of code in an algorithm. This is what the definition of time complexity is. But in simple words, time complexity is nothing but the time taken by the algorithm to run. Now, what is the algorithm? For a code, the step of instructions in which the code runs is an algorithm. That's that simple it is. So the time taken for an algorithm to run is time complexity. There was an interview. There were 2 guys. Their names were A and B. They were given a task to write a program to search for an integer in an array. So they coded the program. Both of them got the result. But only person B was selected. Why? Because his code ran very much less time and it has occupied very less space. In short words, his code was very much optimized. Previously, a few minutes ago, I've said that as the size of the code increases, the time taken to execute the code also increases linearly. So here you could see that the graph here is a linear graph. And you could see an equation over here. You know that the linear equation would be ax plus b. You know that, right? So it is represented in this form. And here n is nothing but the size of the array. Alright, this might look a bit confusing in the sense you don't know why this algorithm came over here and what is happening. Just assume it this way. You have a code where you took some array of size and you wrote some sort of code, and that has an algorithm this an plus b. Now, in order to calculate the order in terms of the input size, here n is the input size, like here n is the size of the array. So in order to calculate the order, we have some rules. So the first rule here is we need to drop the constants. Here b is the constant and we need to remove b. Why? Why do we have to do that? See, here n is the most impactful and the most powerful term. Because let's say you have the value of a as 2 and b as 3. Now I haven't visually kept the values over here, so just imagine. And let the value of n be 1000. Okay. So if I multiply 1000 with 2, then that would make 2000. And if I add b to that, that would just make it 2003. So you could understand, right? B is not creating a lot of impact when compared to n and a. So here, compared to n, not a, okay. Compared to n, b is not creating a very major impact. So we are just removing b. Now you could see that the equation here is t equals an. From this you can understand that t is directly proportional to n. So this, now we can write this as big O of n. You might get one other doubt. What does this big O mean? Big O is nothing but order of. See, it is something like this. You have a program which runs in different times. Like one program runs in one time and the other program runs in some other time, it occupies some space, etc. You have a lot of parameters. In order to represent that, we use this term big O. So it is something like this. See, if there is a program, if that program is, if the program's time is scaling linearly, then we would say that it is of, if it is of the order of n. But if it is running in a constant time, then you say that it is in the order of 1, etc. You have so many such things like big O of n log n, big O of n factorial, big O of n square, big O of n into m, big O of 1. You have so many such things, which we will look at later on, because this is just the beginning. Now, let's look at this algorithm, which is t equals an square plus bn plus c. Assume it this way. You have a code and its algorithm is this. Just don't think of how you got this algorithm. Just understand that this is the algorithm. Now, if you apply your first rule, which says drop the constants, the c will be gone. Now, there is one more rule, which is dropping the lower order terms. Now, what is a lower order term? Here you could see this n is a lower order term. Now we need to even drop this off. Why? Just the same previous reason. That doesn't make a big impact. So we are even removing this term. So we are left with t equal to an square. By this we can say that t is directly proportional to n square. So we write this as big O of n square. Let's look at one more example, which is t equals ab square plus bc square plus d. Here you could see everything is a constant. So if we apply our first rule, which is dropping the constants, everything will be gone and we are only left with t equals 1. 1 can also be written as n to the power 0, since we are talking everything in terms of n till now. So from this we can say that t is directly proportional to n to the power 0, which can be written as big O of 1. So till now, whatever I said, these are all just the basics, how the rules apply and how this big O, what does this big O mean, what does time complexity mean, and to just make you understand all these things, I've taken this example and I've told you these stories and scenarios kind of thing.
You might be confused with some topics in this video, but don't worry. This is just a first video where I've explained everything in brief. In our further videos, we'll understand everything in detail. So don't worry at all. But if you like this video, make sure you hit the like button and please do subscribe to my channel and share it with your friends.